Hello, everyone. Welcome back to our series of simulation. If you remember, we solved the simulation problem, the problem about the gap of a particular assembly. Let me show you what we had here. Basically, this was the gap, estimating the gap. They were giving us three dimensions. X1 is the base, X2 is the left, X3 is the right. They were all normal random variables, and they give you the means to be 105, 40, and 35. And then we were also given the variance covariance matrix, which is a symmetric matrix. Notice that 3, 3, 5, 5, 4, 4, because the covariance between x1 and x2 is the same as the covariance between x2 and x1, of course, and so on and so forth. And we were asked to solve and find the distribution of the gap. First of all, we said that a linear combination of random variables, because the gap was x1 minus x2 minus x3, which is a linear combination of normal random variables, is itself a normal random variable. Okay, so we knew that the gap is distributed normally with the mean equal the mean of x1 minus the mean of x2, that's 65, minus the mean of x2. So minus x1 minus x2, you get 30. So the mean was 30, and then we found the variance using the variance covariance matrix, and we did the math, and we ended up with the variance being also 30, remember? And then we took the square root of that, and we got like 5.4 something as the standard deviation of the gap. So now we want to see how we can solve this using RStudio, and this time we will have to like download another package that allows us to deal with with variance covariance matrices. So let's do that. So let's go to our studio, and as usual, I'm going to clear the environment. Oops, why it's printing here? I didn't notice that. Oh, okay. What's wrong with me? I can't even. Okay. Remove the list equals all the rest. Okay. So here we want to start. So as I said, there is a package called MGCV. Okay, MGCV. So what you need to do is to type MGCV. It's not in your, well, I do have it, but you won't have it. The first time you have to download it and you click on install. And once you do that, you will see it here. So there are two ways to upload it to your program because this is not uploaded automatically. You have to click this button, or you have to type library mgcv between parentheses like you see it written in the console. So one of two things, either you just click on it or you write library mgcv, and you can type help with that to get help, but I'm going to tell you about that in a second. Now, since we already have it, let's go down and start writing. Um, First of all, we are going to run this simulation. So we'll be simulating, we'll be getting data from what we call the multivariate random distribution, multivariate normal uh, distribution. And so we have to upload the mean and the variance covariance matrices. We learned how to create a matrix before, but before doing that, let's say n equals 10,000 as the number of times I'm going to run the simulation. And then I can say mean, which would be the or let's call it just M, okay? M would be, I have to combine the three values. So I'm going to say C 105, 40, 35. Okay, that's the, or that's the vector of means. And then I have to have the variance covariance. So let's call that variance covariance. Oops. And that would be a matrix. But how do I do it? I say matrix. Remember, we created a matrix when we were estimating pi, and we said matrix of zeros. But of course, here I will not enter zeros. I want to create a matrix that has the values that I showed you, the 9 values. I'm going to read them. And notice we said the matrices are filled by columns. And if I want to make them to be filled by rows, I say by row equals true. But in this case, it doesn't matter because it's a symmetric matrix. Whether you fill it by columns or by rows, you get the same thing. So you get 25, 3, 5, 3, 4, 4, 5, 4, 9. Okay, you have to combine these. You make them as a vector. So you have to say C, and then you tell, notice that this matrix, if I give you these 9 values, you tell me, is that matrix has a single row and 9 columns, or 9 rows and 1 column, or 3 rows and 3 columns? You have to tell our studio that. So you say 3 and 3, 3 rows, 3 columns. And now I have everything stored, right? Next, remember we are going to do a for loop. So I'm going to say for I in 1 through n. This time I used uppercase N. Doesn't matter. As I said, I'm going to open and close the braces. And here I'm going to create one thing. Like I would calculate a value. I can call it X, for example, since I'm adding and subtracting X1, X2, X3. So I'm going to call it X. And I'm going to say, give me one entry from the multivariate normal distribution with those means and those variance covariance. So it will give me a value for X1, a value for X2, and a value for X3. How do we do that? Notice it's called the random multivariate normal, RMVN. Instead of saying R norm, we say R multivariate normal. How many? I just need one row. Notice it's not one value. There are 3 values. Why 3 values? Because I have 3 means and 3 variances and 3 covariances. It asks me what means should I use? And I say the one stored in mean, in M. I'm sorry, I called it M this time. I was typing mean but I didn't want to use mean because mean is a function. So just to reduce confusion, in fact, it wouldn't allow me to use mean. So I'm going to do that. So once I run this, it will store 3 values. 3 values. Okay? And then I'm going to say, I'm going to create a matrix called gap. You say, why didn't you create it in the beginning? I could have. I could have said gap is a matrix of zeros that has 10 or n rows and 3 columns, for example. But no, just 1 column because we are going to calculate gap. I can say gap of I equals should be x of 1. X of 1 minus x of 2 minus x of 3, I think. I think it should work. Let me run this and see. No, gap not found. Yeah, I didn't create gap. Huh. Didn't I say gap? Okay. Gap. Yeah, I'm sorry. It's my mistake. I should have. In fact, I noticed it and then I said, I think it would work. Gap is a matrix. I can make matrix of zeros with n rows. It's only 1 column, okay? Because I'm going to calculate. Let's see if that worked. Yeah, that worked. So if you open gap, you will see 10,000 values. I ran it before completing it, but just to show you. But here I have to say mean of gap. I should expect a value not exactly 30, but close to 30, and standard deviation of gap. Let's run it and see. Okay, so if we run this simulation, oops, yeah, you get, oh, I did standard deviation. I should say var, but it's var. Okay, let's run it. You see 2988 or 89 to 2 decimal places and 2945, very close to 30 and 30, right? And of course, if you run it again, you'll get slightly different values. So now it might be it might be a case where someone would tell me, suppose I was solving this problem, okay, and I want to enter the answer. So I type the answer and everything in a report, but then when my teacher told me to reproduce it, I run and I will get different values. I say, oh my God. So how do I correct that? How do I guarantee, if I want, that whatever value I generate will always be generated, meaning I can reproduce the exact simulation. This is done by creating or by setting the seed. A seed is a value that if you fix it, the simulation will use the same exact numbers because they get them from the same exact location. So what you can do here after you clear, you can say set dot seed. It's the first thing. I didn't type anything. You click tab and you fill in any number of your choice. Maybe I can use, I used to tell my students in the exam because, each one will have different, I want them to have different values so they can copy from each other to enter the seed as the last 3 or 4 digits, not of their social, but of their uh, the identification number in school. So they have to write their identification number on the front seat with their name on the front sheet, and then they enter the same last digit. So if I can enter anything, 1624, for example. Okay, let's run it. Okay, I got 30 point that and 2938. If I run it again, I'm not going to get any different values. It's still 30.017 and 29.38. It's the same. They are the same values. You see here, 30.01756, 30.01756. Same thing with the variance. So that's if you want to keep the same answer for later, or if you and your friend are working on a project and you are doing a part and they are doing a part and you are taking values from their output as your input, of course, you need the same numbers, right? So you share the seed, you set the seed at a specific value, and then you can complete your project with numbers that are consistent. They don't change. I'm not going to write something on my side and then my friend is using different numbers as their input and I say, where did you get these from? They are not the same as your teammate. Okay, so I think this clarifies that. Next time, I'm trying to find some more interesting, in fact, some funny things. Like I will try to find a couple of examples of simulation that we can use because we will need those. Remember when we were doing the confidence interval, and I told you, if I'm doing a confidence interval for the mean and I know the variance, which nobody knows, or the sample size is so large, I can use the z, otherwise I use the t, but if I use the t, meaning that my sample size is small, I have to make sure that the distribution is normal. So what if the distribution is not normal? Or if I cannot guarantee it is? Then I told you use something called bootstrap. So that's maybe a couple of sessions. I will show you how to do the bootstrap. In fact, there is a bootstrap function in RStudio, but it's not that hard. I will show you how to create your own, and you can find anything now. A confidence interval for the mean, standard deviation, the median, anything using that method. And I think you would like it. Thanks for your time and hope to see you soon. Bye. So.